Wait, oh, sorry. Should I change
That's
my name because you both have like first name, last name? I didn't do that, but maybe that doesn't matter.
Nah, doesn't matter. No big deal. No rules. So, okay, I'm going to start. Perfect. Yep. Hey everybody, Brian Redmond here. Another video for our AKS YouTube channel. Very, very excited to cover our topic today, which is about Fleet Manager and using it to upgrade fleets of clusters, fleets of AKS clusters. So I have two special guests here. If you guys could do quick introductions, that would be great. Just kind of tell us your name and what you do on the team, and maybe something interesting about yourself that most wouldn't know. You want to go ahead first, Shashank?
Hey folks, I'm Shashank. I'm a PM on the AKS team. I work on multi-cluster, service mesh, and identity areas. Fun fact about me, since I'm wearing a Gryffindor shirt, I'm a big fan of Harry Potter, and yeah, I'm a Gryffindor by heart. Over to you, Stephane.
Love it.
Hi, I'm Stephane. So I'm an engineer on the AKS team. I've been focusing on the fleet experience for the past year plus, together with Shashank and the team. Fun fact about me: I'm French, like my accent might give away, but I live in Australia.
Oh, awesome. Well, great to have you both here. And before we kind of dig too deeply into the topic around upgrades and so forth with Fleet, I think it might be good to kind of take a step back. I think people that are new to Kubernetes or AKS, they may think that it's just easier to set up kind of one giant cluster and have all the different sort of app teams throughout a company work with that single cluster. Now we know that's not true, but it might be interesting to kind of hear like why do companies end up with these giant fleets of clusters, and why did we build Fleet to help those folks out?
Great question, Brian. So I'll start with a quick introduction to Fleet. So we often are asked, what is a fleet? Fleet is nothing but a group of Kubernetes clusters. Most of our big customers, they don't have just one or two clusters, but they have hundreds, and some have even thousands of clusters. And with these thousands of clusters or hundreds of clusters, there also comes problems about how do you manage these clusters at scale, whether it's with respect to lifecycle management or deploying applications across these clusters, making sure that they're optimally utilized. How do you set up networking for these applications, whether it is east-west communication across clusters or whether it is spreading incoming traffic across clusters. So there are a whole bunch of problems that one has to grapple with when they're dealing with the platform of these Kubernetes clusters rather than singleton Kubernetes clusters in isolation. In terms of why a customer would want multiple clusters, we've seen many reasons, but a few of the common ones are one, for resiliency purpose, so that one cluster going down shouldn't impact the entire application. Rather, they spread the application across multiple clusters so that these apps are resilient to single cluster failures. Next, we have seen few customers with a large number of calls going to ARM also want to have different clusters across different subscriptions to get around these limits. There are some clusters, some users who want to have different clusters in different regions for data resiliency and proximity purposes. Almost all our users have clusters in different environments, test, staging, and prod. In terms of multi-tenancy, there are a large number of users who go for namespace level multi-tenancy on a single cluster, but there are some other security conscious customers who want to have clusters itself as forms of isolation, stronger isolation, and hence they have multiple clusters for that purpose. And there are also some other users who have presence on multiple cloud providers, so that could be GKE clusters or EKS clusters, or you could also have clusters on-prem. So here are a few of the reasons why we have seen our users have multiple clusters. And what challenges did this create? As I mentioned briefly earlier, lifecycle management of the clusters. So that's to do with upgrading the clusters, whether it is the Kubernetes version or the node image versions. Next, how do I deploy the same app across multiple clusters? What if I want to specifically target a subset of clusters rather than all my clusters? How do I achieve topology spread? So those are a few of the things with respect to app deployment. And then on multi-cluster networking, it's both the east-west and the north-south. East-west, we are now starting to get a lot of us about multi-cluster service mesh. And for north-south, we have app gateway for containers for single cluster, but we are also getting a lot of us for providing the same capability from a multi-cluster perspective too. Next, even before Fleet existed, also just want to call out that there are more cross-cluster scenarios too, and Azure Resource Manager has had other experiences like Azure Monitor and Policy help with this at-scale management scenarios. For instance, if you want to have a centralized dashboard across all of your clusters for monitoring, you can go to the Azure portal, search for Azure Monitor, and there you'll get to see a list of all the monitored clusters, and you can build your dashboards and everything from there. Similarly, with Azure Policy, you get a central dashboard from where you can view all your audit results. And with Azure RBAC, you get to create role assignments at the resource group or the subscription level, and those get inherited down to all the clusters under that scope. So we have had other at-scale experiences with respect to fleet of clusters too. But with Fleet, what we are now introducing is a grouping construct, wherein you can group clusters from different subscriptions. You can group them from different resource groups. As long as they're all within the same tenant, it's fine. And with that grouping construct that is Fleet, it provides a foundation for us to overlay these different scenarios on top. For instance, you can use Fleet and update runs for lifecycle management of the clusters, which Stephane will be speaking about in detail in a few minutes. But there are also other scenarios like Kubernetes resource propagation to deploy workloads across multiple clusters. We have multi-cluster L4 load balancing today, wherein you can spread the traffic across the same services endpoints on multiple clusters. So we think of Fleet as a grouping construct via which all of these multi-cluster scenarios can be addressed. And we see more and more of these scenarios, such as multi-cluster mesh in future, getting added on top of the Fleet resource. In terms of the Fleet and its layout, Fleet is a lightweight grouping construct, as we mentioned. So if you're using Fleet only for scenarios such as update orchestration, it is just an abstract grouping resource at that point of time. But if you want more scenarios such as Kubernetes resource propagation, then Fleet also comes with AKS hub cluster. It's a single node AKS hub cluster from where you get a Kubernetes API, and you can use that Kubernetes API to create cluster resource placement policies, for example. So that's the overview of Fleet. With this, I'll hand it over to Stephane, who will actually give a demonstration of how to create a Fleet resource, how to associate the members, and then how to use update runs to manage the lifecycle of these member clusters. Over to you, Stephane.
All right, awesome, Stephane. I'm going to put your screen up. You're going to do demos all the way from Australia. Appreciate it.
Yeah, hopefully the network connection works. So yeah, as Shashank mentioned, Fleet Manager, the Fleet is just a grouping construct, and in the portal in Azure, it translates into being just an Azure resource, another Azure resource of type Kubernetes Fleet Manager that is in a resource group. So I pre-created some of those resources just to get the demo a bit smoother. But the Fleet resource provides you first, and the first thing it provides you once you have joined your clusters to it is a really nice dashboard that gives you a perspective over what clusters are in your fleet, what version they are at today. There might be at different stages. The dev cluster might be ahead of the production clusters. It shows you which node image version are deployed across your node pools in all the clusters, and some more information about the multi-cluster updates, which I will get into really soon. We also start providing some warning, as you can see here, like which member is on the deprecated version, and plan to provide quick actions to be able to bring this cluster back into a supported version, for example. So let's take a look, for instance, at the update run. Once you have that many clusters in your fleet and you need to manage them, one of the pain points is to keep them up to date. So AKS has has auto upgrade at the cluster level, and then each cluster will be triggered an auto upgrade to stay on the patch version or on the node image version, the latest node image version. But if you have different environments, many people want to structure the upgrade in a staged way and be safer to deploy the latest Kubernetes version first in dev, then in staging, and then in different prod region at a slower pace to ensure it doesn't trigger any outage. With auto upgrader at the cluster level, you don't have that much control unless you tweak the maintenance windows. Now with Fleet, you can model that with a workflow. And so if we take a look at the update runs that I have already run one prior to show you the output and how it looks like. And so I upgraded dev and staging to 127.7. And we can see here that it was completed successfully. It upgraded 6 clusters. We have when it was created, when it was started, and that it was in stages. And so if we go a bit further in there, we can see the details of which cluster were upgraded. We have a bit more details when it was completed as well, who started it, who created it. And here we have the dev stage, which upgraded 3 clusters and completed, and we can drill down to each cluster still. So now let's look, how do we create this and how do we create that workflow? So if I go back to my multi-cluster updates, I have runs, which is each time upgrade, and I have strategies. So I can create strategies that will define the stages in which we upgrade the clusters. And within the stages, I can define groups, which are then included in each stages. So if we look, for instance, at the fast deploying stage that I created here, I created 2 stages, one that includes the dev group and the staging group, and then a prod stage, which includes the prod 1 and prod 2. So those groups are defined on the members. So let me skip back down to the fleet itself. I might have gone a bit too fast. So if we look at the members in that fleet first, we can see that I have not all my members listed here that are pointing at given AKS clusters. And here we have update groups. So I assigned groups to each of my members. And I say that fleet member 6. So if we look at our clusters sorted by groups, we have the dev members, which includes those 3 clusters, are on 127.7. We have the prod clusters, and I've separated this in 2 different sections, prod 1, prod 2, and they are on 126.10, and then we have the staging clusters here. So those groups are what you see then in the flow that goes through stages and groups that upgrade each clusters. So let's go back now to multi-cluster updates and our strategies. And now, so we have dev and staging only, which is what I started before, run through before, upgrade only dev and staging groups. And I created fast deploy in stages, which has dev and staging together with update groups, dev and staging. And so you can see the stages are going in sequence. And if we go one level further to take a look at what that stage consists of, here we can see that the stage we have includes the dev group and the staging group, which clusters are being targeted by this here. And the explanation here that is collapsed shows to you that a stage will run in sequence, but all the groups within a stage will run concurrently. So that means that when I hit this stage, I hit the dev and staging group here. The dev group and the staging group will progress in parallel, and the fleet member 8 cluster will upgrade at the same time as fleet member 5, and then we move on to fleet member 0 and fleet member 1, and then finally to fleet member 4. Right, so let's create now an update run based on this strategy. So if I go on the runs here and I click create, now I can say that I maybe want to go to 128.5. And I'm going to keep, I can do one by one, which means I just won't care about stages and just do cluster by cluster, one by one. But that's a bit simplistic. We want stages in that case. And so I can now choose to copy from the existing strategy. And I have my 3 strategies with some level of perspective of what will happen here. So I see that I have fast deploying stages. That's the one I wanted. Select. That one's end up here. Now I can still modify it if I want and say, oh, I don't want to do prod, just staging. And that won't impact my strategies, but I'll keep it this way. I want now to target a specific Kubernetes version. I'm going to say 128.5. And here I can choose whether I want the latest image. So that means each cluster upgrade, we leave it to AKS to pick the latest image that's available in the region of that cluster. And that means that you might upgrade, when you reach staging, your staging cluster, you might have image version 1, and you move on, and by the time you get to prod, maybe the prod region has already the next version of the node image version because you progress slowly, and maybe prod gets the very latest image version which hasn't been tested in there. So that's fine for some people, and for others, they want a safer way to ensure that the image that's deployed in dev is the same that's going to be deployed in staging and in prod. And so I can choose consistent image here. And Fleet will ensure that we pick the image version and we deploy the same across all the clusters. And we create that update run, which shows up here. And then I can still choose when I started. So here I can take a look at the update run. I can verify that everything is as I expect. I have a post duration after the dev staging step. And at that point, I can still edit it. I can still change things. I haven't started it yet. And now I can just trigger the upgrade. And that will kick off my workflow. Now I move into a running state. And I can see that the dev and staging is in running and has 5 clusters to upgrade. So let's take a look at the details. We can see now that the dev group has started and the staging group has started. Fleet member 8 is running the upgrade, and Fleet member 5 is running the upgrade concurrently. And we progress through. And once all those clusters are done, we'll wait for 10 minutes and we'll move on to prod. This wait period is configurable, and you can set it to days if you want, to let you verify that everything is fine, bake it in dev and staging before moving on to the next step.
It's pretty powerful. Obviously, that we hear from customers that upgrades and controlling upgrades and keeping things safe during that process is really important. It's one of the biggest, I think, struggles for some of our customers, at least what we hear. I would imagine I could even like take a group of, if I have a really large number of production clusters, I could take a small group of those and label them as, say, Canary, and do an upgrade on the Canary group. I mean, we're using prod, dev, staging just because it's for the purpose of the demo, but obviously I could get creative with this. I could do whatever to kind of map to ensuring they have proper kind of health when that upgrade occurs so they can keep it progressing. I like that there's these big delays that you can add to control that a bit.
Yeah, that's correct. You can model your groups the way you want to match. Maybe you're going to have it based on some cluster are dedicated to some parts, some applications, and some others to other teams, and you want different. You upgrade them at different pace because it depends on what application runs on those clusters. And so you're able to group those clusters, label those clusters, and then create update strategies that matches the topologies of your clusters and the way they're used in your environment.
Yeah, awesome. Well, I imagine folks after seeing this are going to want to kind of dig in. We only saw, this is really just one function of Fleet Manager. I think people are going to want to go learn more. First of all, we'd probably want to have you come back and show some other demos of other fleet functionality. But in general, where can folks go to kind of learn more and get started with this?
Shashank? Oh, I think you're
your
muted.
slides. Yeah, I think you're muted, but.
Okay, sorry about that. I was finding the unmute button, but yes, about where to go. So we have a lot of resources. The best place would be to start with our documentation. It has a lot of details about how to create a fleet, how to create update runs, update strategies, and this is for not just for CLI, but for Azure Portal and everything that Stephane just gave a demo of. So that feature is generally available right now, but strongly recommend trying this out if you have a large number of AKS clusters. So you would want control over how you upgrade those clusters in the sequence. So definitely go for the documentation. Within the documentation, there are also some preview features as well. As I was mentioning earlier in the call, there is a feature about how do you place your workload across multiple clusters and how do you control which clusters to place them to. Topology spread, cluster affinities. There's a whole bunch of goodness out there if you are operating a shared Kubernetes platform where you have to spread your applications across multiple clusters. We would strongly recommend taking a look at that too. And that's something that we are adding more capabilities on very soon. So we would love to hear feedback if you have on that feature as well. There's also another feature about multi-cluster L4 load balancing, where you can set up service across multiple clusters, declare service inputs, and then set up a multi-cluster service to have incoming traffic spread across multiple the service endpoints across multiple clusters. That's currently a preview feature as well. Beyond that, our roadmap covers a lot more capabilities that are coming down the pipeline. For instance, on the update run feature itself, we are currently working on adding auto upgrade profile at the fleet level. We have a GitHub issue for that, but if you have more feedback upon how you want that feature to kind of shape up, we would love such feedback on those GitHub issues as well. There are also some other things such as multi-cluster service mesh and cross-cluster object browse experience in the roadmap. We would definitely love your feedback on how you want those experiences to run, and happy to engage and add more things onto Fleet.
Yeah, awesome. And I think that's a great point to bring up. I mean, this, for folks listening, I mean, this YouTube channel is directly the AKS and Cloud Native Platforms engineering team. So feedback, questions in the YouTube channel, wherever that might be, it goes directly to us. And we do value that feedback. It really drives a lot around what we're building. So with that, we'll wrap things up. Thank you, Stephane and Shashank, for being here. I thought it was great to hear what we're doing with Fleet. Really powerful functionality we have there to help us keep things up to date in AKS. So thank you, folks. Appreciate it.
Thanks for hosting us.
Yeah, awesome. See you folks soon. Thank you.
Take care.
Bye.